Gentlemen, please welcome to the stage Mr. Jonas Stromberg.
Thanks. Thank you very much, everyone. Pleasure to be here. Thank you very much for inviting us. I will be trying to whiz you through a number of slides here and talking mainly about, let's see if we can get this moving. Yes, I will mention a little bit on our view on sustainable transport, and I will talk a lot about what we have to do here and now. But of course, since the topic is the future, I will also look into all the exciting innovations going on within the heavy-duty industry. And I will try to show a few good examples as well, but I'm really looking forward to the discussion afterwards and some really good questions from you guys. Let's start very quickly with a small observation. We are moving into a city world, a world that will be dominated by cities. Most people will live in the cities in the future. Already 2/3 of the population might live in cities already by 2030, meaning that cities will be using most of the energy, but also causing most of the emissions. The growth of these cities are not in the old world. It's not here in Europe. This growth is happening in Asia, India, and Africa. And one conclusion that we really have to make is, unless we find sustainable solutions, and in particular sustainable transport solutions for the growing cities in this part of the world, unless we do that, there will be no real sustainability globally. That's really important. We tend to be a bit Eurocentric over here at times. Of course, we really need to do a shift, and you have heard all the previous speakers mentioning it before. Of course, mobility will triple in the cities we talked about. That most of the cities are not prepared for this dramatic increase in mobility. That will lead to congestion. It will lead to air pollution. Air pollution is today already the #1 killer of the world. 1 out of 8 deaths comes from poor air quality in cities. And very unfortunate is that heavy-duty vehicles, such as trucks and buses, very often tend to represent over 75% of particle emissions in cities. So we have a huge responsibility to clean this up. Energy security is also a big issue. Over 90% of the transport of the world today is powered by fossil oil. We need to get out of that addiction. We are really the oil junkies of the world. And climate change needs no further introduction. It's already here. And CO2 from transport is growing very, very quickly. You're familiar, of course, with the Paris Agreement, which is a great step forward, where the world is finally uniting to fight climate change. But I really want to stress the urgency. Our time is running out, and running out very, very fast. We have already used most of the carbon budget that we have in order to reach the Paris Agreement. If we carry on in the same pace as we do right now, we have 12 years left. 12 years. That's not a very long time. After that, we will have less than a 50% chance to achieve the Paris Agreement and to achieve 1.5 to 2 degrees increase in temperature. Unless we succeed in doing this, we will face a very hostile planet. So time is really short. So what we have to do, basically, is to start halving the CO2 emissions every decade. This is what science is telling us. And that is a very, very tough task, but it has to be dealt with. If you look back the last 20 years, we have managed to cut down around 25% of CO2 emissions. Now we need to start halving them every decade. And of course, there is a special pressure on the transport sector. This is just an example from Sweden. We have managed to decarbonize basically every part of society, from industry to heating to housing, electricity production. These are actually the easy parts to decarbonize. Then there's one other sector on top, it's transport, where we are still not succeeding really. Oil dependency and CO2 in the transport sector will be in focus. This is really the tough challenge that is remaining. So the eye will be on the transport sector for these 12 years. What can we do? It's quite obvious, and you heard it before also from the previous speakers. When we design the new transport solutions, the new transport products, they have to be low carbon, that's a given. They also have to be clean, but of course, heavy-duty vehicles also have to be commercial. Heavy-duty is not the car. You heard it also before, a car is used 4% of the time. A heavy-duty vehicle could be used up to 24 hours around the clock every day. It weighs up to 60 tons, so it's a very different game from cars. And this is sometimes where policymakers go wrong. They try to make the same decisions for transport as they do for cars when they look at commercial transport. We will talk a little bit more about that. So what we have to do, I would just like to summarize it because time is short. It is quite obvious. When we design the new solutions and the new products, they have to be clean, they have to be low carbon, but they have to be so commercial that they can outcompete diesel in total cost per kilometer, including everything. That is the basic and simple truth about what we have to do. And this needs to hold true not only in rich cities in Europe, it needs to hold true also for all the growing markets of the world. So how do we go about to do that? There is no silver bullet, there is no one single solution to solve this, there is no one thing to solve to replace diesel. We need to work with 3 basic pillars. We need to be more energy efficient in our solutions. We need to transport things and people in a much smarter way than we do today. And we need to replace the fossil energy in the system with clean and low carbon energy. Lots of activities going on in each of these fields, but I will focus a little bit on the here and now, what we can do here and now, and I will focus on the smarter transport and the decarbonization. I will not talk much about Scania. I think we are well known. I just want to tell you that we have a long history. Founded back in 1891, but I really want to point out that we made our first fossil-free vehicles back in 1916, when we had the first ethanol engine, and a few years after that we actually had the first gas engine as well. So this is not new technology. A little bit of an ongoing innovation over these 100 years. Scania is famous for its modular system. And what is that? To explain it very easily, it's a little bit like the Lego toy. Every part we do when we design a vehicle needs to fit with every other part. So we can use as few parts as possible to design as many different vehicles as possible. So a little bit like Lego, if you think. The big advantage of this is, of course, that we can industrialize in a cost-efficient way. So when we design also an alternative energy or an alternative driveline, we can use the same modular system, only changing a very, very limited number of parts. And this means that we can make this commercially, and this is really the trick. Any engineer today can put a vehicle on the street operating on electricity or orange juice or whatever you like, but to do it in an industrial way, so you actually can sell a commercial product that can be sold at a cost-efficient cost per kilometer, and that can also operate for 20 years with service, maintenance, and everything. That is really the trick. We need to industrialize sustainability, and that's what we are good at Scania. That is also why we have a very large portfolio of existing here and now solutions to decarbonize. We have basically a case where all our diesel engines can operate on biodiesel. We have a diesel type engine that can operate on pure ethanol, bioethanol. Only 14 parts differ in this vehicle from a traditional diesel vehicle. So this is really, again, coming back to the modularity. We have, I will come back to that, we have the most efficient gas engine in the world, where we can operate both on CNG but also on biogas, which I will come back to later. We have hybrids, we have our electric vehicles, and of course we also have the clever bus systems that I also come back to. All these things are here and now, off-the-shelf solutions that can outcompete diesel and that can reduce CO2 emissions with up to 90% already today. These type of solutions need to be applied broadly if we should break the CO2 curve. All these different alternative fuels are not only low carbon and clean, they actually also contribute to local energy security. They create local jobs as well. And we work with a number of partners to make it possible to apply these solutions on different markets, because different energy solutions are more suitable on different markets. So we cannot do this ourselves. We cooperate with a big number of fuel, biofuel, bioenergy, electric and gas partners around the world to be able not only to sell a vehicle and say good luck, but actually to sell a complete solution that the customer can use for over 10 years in operation in a safe and stable way. We have a lot of partners. I'm just showing you a few of them. And we also have a few local partners throughout the Baltics here that we cooperate with. Again, just coming back to, I hope, to stress why it is important that we apply the biofuels here and now. You remember the 12 years that we had. If you look at the vehicle market today, less than 1% of the vehicles on the market today are electric. And the average life of a vehicle is somewhere around 12 to 20 years. So if we want to break the CO2 emission curve from transport, we also need to decarbonize the existing portfolio. And that we can actually only do with the liquid biofuels today. So that is something that we really have to do. What is also interesting in Europe is that we are only using 50% basically of the capacity for producing biofuels. We already have the biorefineries available that could double their production tomorrow or the next season, basically. If that was done, we would actually, that alone would be enough to break the CO2 curve in Europe from transport. Such big is the capacity that is not being used. And also for the future, hard to decarbonize sectors like maritime and aviation will also need these liquid biofuels. So to waste that possibility, not using that capacity in Europe, is really, really a waste. Of course, big discussion going on about are biofuels really sustainable? The good news is that they are. We have now in Europe in place a very strict sustainability legislation, ensuring that all biofuels are reducing 50 or even more than 60% of CO2. There has been a problem previously, particularly with palm oil from Indonesia, that has given biofuels a really bad name, but those are phased out, and I think that is a really good development. What you see here is actually 25 million hectares of unused farmland. Europe has actively abandoned its farmland and its farming sector since the 1920s. So we have 25 million hectares that we are not using, but we are actually subsidizing the farmers not to use it. What is 25 million hectares? Well, it's 7 times the size of Belgium. Unused farmland. That farmland alone could actually make Europe energy independent on fuels. It's a really shame that we are not using it, but the possibility is there, and it could be utilized really, really quickly if we start using it. Okay, another here and now factor is, of course, smarter transport and public transport. That is a really smart thing. When you buy a bus, usually in a city, where do you put it? Well, usually you put it out to the right in the traffic. That's not where you should put it. This picture quite clearly illustrates where you should put it. You should put it right here. Just like when you buy a train, because when you buy a train, someone has been really nice and put out some tracks for you. If you think the same way, when you apply it to bus operation, you get something that is called the bus rapid transit system. That is a really attractive and a really efficient way of transporting people. And we really need to make public transport efficient and attractive to get a shift over from the car to the public transport system. What is also good with the BRT systems is that you can actually build it up piece by piece, and you can get a really high capacity. You can transport as many people as the finest metro in the world, which is actually happening in the system you just saw, which is from Bogota. But you can do it at 10% of the cost of a rail system. This is a really important solution to implement, particularly in the rapidly growing cities of the world, where you need transport. It's quick to implement, and it can grow in a flexible way together with the city, as compared to some of the rail system that takes up to 10 to 20 years to implement, and they are very costly as well. When you implement these systems, you get attractive public transport, you get people out of the car into the public transport system, and you power the public transport system with a clean fuel. You have virtually reduced 98% of emissions, and you have a really here and now sustainable solution. This is something that can be done big scale all over the world today. When we sell these type of public transport systems, again, we can not only sell a vehicle and say good luck, we actually need to support with the project planning, with the financing, with the fuel, with the vehicles obviously, with the service and the maintenance, with the training of the drivers, and all the things around here. So as you can understand, being a vehicle producer is not being a vehicle salesman. It's about partnerships and solution sales that takes quite a long time to plan and do. So it's all about doing partnerships. I'd like to come back to another favorite topic. It is turning waste into clean fuels. Today, 95% of all organic waste in the world goes into landfill. That is not only waste, it's really a waste. That waste can be turned into probably the most CO2 efficient and clean fuel that you can think of, biogas. And this is something that we have done for over 20, 30 years in the Scandinavian countries. For some reason that has been kept sort of as a secret. And we really would like to expand and export that solution a little bit more. I will try to show you, or at least with the help of my friends at the other side, to show you a little movie on this topic. To see if that can happen. Great.
Waste is a growing global problem. A mere 25% of all garbage worldwide is recycled, composted, or digested. 1/3 of all food produced goes to waste, including almost half of all the fruit and vegetables grown. Basically, all organic waste ends up in landfills. There, it decomposes and creates methane and carbon dioxide, which are released into the atmosphere with dire consequences. Landfills leaking toxics and chemicals that poisons our soils and freshwater supplies for no good reason. Yet, at the same time as the garbage heaps are piling up, in some places, a small revolution is taking place. In Sweden, 99% of all household waste is recycled and transformed into animal feed, biofertilizer, and energy. The landfills are basically gone, and instead of being a problem, waste has become a resource as food scraps and other organic waste are used to produce biogas, bioethanol, and biodiesel. Locally produced fuel leads to better environmental solutions and clean, low-carbon buses and trucks on a global scale. This means not only attractive transport, but also fewer landfills, lower carbon dioxide emissions, and less use of fossil fuels, improving environment and health, creating local jobs, and reducing climate change. Scania and our partners offer complete waste-to-fuel solutions with proven technology addressing your city's waste, energy, and emissions challenges. You can't run from the waste problem, but you can drive away from it in a Scania bus.
So a little bit of propaganda there on the waste revolution, sorry about that. Basically, going back one generation, we were as bad as anyone else. We put most of our waste into landfills. Through a number of quite active policies, we have now reduced the landfills to zero. But what do we do with the yuck instead? Yeah, we actually turn it into clean energy. And now most of it actually goes to fueling our heavy duty, particularly the bus, the waste trucks, and also the distribution truck fleets. 91% of the gas on the Swedish vehicle gas grid is biogas. 91% from waste. And that is possible everywhere else as well. So when you look at this, and I do a lot, my fair share of walking around on waste dumps, when you look at this, you might see waste, you might, I don't want to go there. This is actually the gold that we are looking for and that we should use. 95% of this still goes into the ground. That is something that has to change. A really good reason for using biogas is that it is by far the most climate effective solution that we have here and now. If you look at the typical CO2 emissions from diesel, biodiesel, natural gas, then in yellow you have the typical electrical pathways, and then in green you have all the different ways of producing biogas from different sources. Biogas always outperform all the other solutions for decarbonizing. And that's why it's so important to always look at the well-to-wheel perspective on your emissions. If you just look at the technology, you don't know. You have to see what are the real emission cuts. Biogas is actually the only fuel that can recycle carbon as well, up to 3 times as much. It could be actually minus 350% if you make it particularly from things like dairy waste and manure that goes into landfill, that breaks down, decomposes into methane that goes into the air. When we take care of that, we actually have negative CO2 reductions. Really, really good. Biogas is not only about creating a clean fuel. The biogas itself is actually a byproduct of something that is true circular economy in practice. What we do is really to take care of waste and to clean water. And as byproducts, you have biofertilizer that can improve your soil. You have the biogas fuel, but you also actually take a lot of CO2 and emissions out of the system. So it's a really true circular economy in practice. Around 1,500 people, if you take care of the organic waste from so many people, you can power a bus or a truck for a year. That's quite impressive as well. One good example, of course, we have to mention Stockholm. We're from Sweden. There are no fossil buses or waste collectors or distribution trucks in the city of Stockholm, or in the whole region of Stockholm, I should say. They have been phased out, being replaced by biogas, bioethanol, biodiesel, and electric hybrids. All done on a full commercial scale, outcompeting diesel in the cost per kilometer. Region of Kalmar is doing the same. It's in the east part of Sweden. The cities have teamed up with a big agricultural business, taking care of all the waste from the agricultural sector as well, turning that into biogas, powering all their heavy-duty vehicles with biogas as well. Really good business for the region. Our friends in the UK are doing biogas in many cities at the moment. I just wanted to leave you with a quote from our biggest biogas customer in the UK. He is actually operating these vehicles on 80% of the cost of a diesel vehicle, and he has higher uptime. So this is also commercial sustainability, really, really commercial sustainability. And on the top right, you actually see that this is also the fastest bus of the world, because it was on Top Gear. I'm not sure if you've seen it, but there is a link you can click and you will see the fastest bus in the world. It's actually a biogas bus as well. Really, really happy to say that we also have a good example. You don't have to go to Sweden or to the UK to have a look at this. You can actually go to Tartu here in Estonia to have a look at 64 biogas buses in operation. Really, really good example locally, and I hope it spreads throughout the Baltics. Also, and coming back to Bogota in Colombia again, the biggest public transport system in the world, transporting more people than the biggest metro in the world by bus. They decided to renew the system this year, and the choice was actually to use Scania gas buses. And we are also now looking into the possibility of fueling all these buses with biogas from local waste. So really a few good examples from around the world. Our gas engine, when I was a customer buying vehicles some 15 years ago, we thought that the gas engine was weak. It was consuming a lot of fuel, and that was actually true. But over the last 15 years, there's been a tremendous development of the gas engine. Today, the gas engine is stronger than the diesel engine. It is more quiet, and it is a lot cleaner. It is simply a better engine. Again, also being quiet, it's certified according to the European Quiet Vehicle Standard, which makes it possible also to deliver things at night. With a quiet vehicle, opens up for more business possibilities, 6 more hours. So it's a very, very good vehicle. A little bit of the future innovations then. We are operating the first e-highway in the world. Basically, we have electrified a part of the highway in Sweden, and now this is also happening on 3 of the autobahns in Germany, where we run a truck. It is, again, coming back to the modular system, our electric hybrid truck that has been equipped with a pantograph, so it can run fully electric while on the highway, and then operate as a traditional hybrid when operating on the smaller roads. We have also using exactly the same driveline for our buses when we try with inductive charge. when we do the pantograph bus operation. But also we use the same driveline when we power our first fuel cell test vehicle in Norway. So this is all about actually that we design the driveline so it doesn't matter where the electricity comes from. If it is a battery, if it is on a pantograph, or it is from a fuel cell. And when you design your electric systems, you also need to think well to wheel. If your electricity is dirty, you will actually have more emissions than if you operate the diesel vehicle. And I would just like to show you another short clip on how we do this when we operate our electric buses.
Det är ett väldigt intressant projekt utifrån flera perspektiv. Om man börjar med det faktum att klimatförändring är den största utmaningen i Sverige när det gäller transporter. Och transporter måste vi hitta nya lösningar. Det pågår en stor omställning inom hela transportsektorn. Det pågår en stor omställning inom energisektorn och här kan vi få den synergierna på plats som verkligen visar sig i det här projektet.
Här har vi Bilsta kraftverk. Det är ett av de 3 kraftverken som Hjälpkraft har gjort i Bilstaån. Bilstaån är ju 3,5 kilometer lång. Här har vi gjort 3 omlöp, så kallade förbifarter. Och i Bilstaån så är det nu, man kan säga, hög andel biologisk mångfald i vår elproduktion. Här går fisken, andra akvatiska organismer. Och vi levererar ju då naturligtvis då den här elen då till elbussprojektet då i Östersund.
Nej, men det är ganska roligt för att vi har haft, under den kallaste perioden i våras så hade vi minus 30 grader och den varmaste perioden nu i sommar har vi haft plus 30 grader. Och vi har ju inte haft några problem med våra elbussar, utan de har ju gått i ur och skur om man säger så. Nej, men det är som jag säger, vi är imponerade. Det har vi alltid varit över Scanias sätt att ta sig fram. Det har flyttat på bra. Vi har haft en underbar övergång med förare som har varit jätteintresserade, som har verkligen satt sig in i det här projektet och vill att det ska fungera på ett bra sätt. Och vi är jättenöjda med den satsning som har varit.
Ja, de flesta jag har pratat med, de tycker att det är riktigt skönt att åka i dem. Det är tyst och så är det behagligt. Jag har till och med haft några som har velat åkt ett varv bara för att få känna på hur det är att åka elbuss. Så att ja, de flesta tycker det är underbart att åka.
Ja, det är ju skillnad på el och el också, därför att fossilproducerad el, exempelvis med kol, har ju då den stora klimatpåverkan kan man säga. Medan då den här elen som vi producerar här i Bilstaån, den är ju då helt förnybar och är också koldioxidneutral.
Det kommer att gå fort och det kommer att behöva gå fort för att vi behöver nå våra klimatmål. Och vi ser också ett efterfrågan som ökar mycket snabbare än vad vi trodde. Städerna vill ha en ren och tyst transport som är effektivt och det är något som vi kan erbjuda tillsammans.
So really important when you design your system that you look at the well-to-wheel emissions. So you also need to produce your electricity in a good way when you do this. Just to end up with some of the development, we have the biggest fleet of connected vehicles in the world. So we have been basically following through the little black box all our vehicles that has been produced for the last 10 years. With this, there is just, I think we are just scratching the surface at the moment for what we can do. But the connected vehicles opens possibilities for really sort of real-time driver training and coaching. The difference in fuel consumption between a well-trained driver or an untrained driver could be up to 20%. We can do fleet management, we can do flexible service, we can actually even give an uptime guarantee, so we can guarantee that the vehicle will be on the road for at least 97% of the time. We can do platooning and we can do autonomy. And we can also do zoning through geofencing. Our vehicles can now actually feel when they come into a speed limit zone or a low noise zone or an emission-free zone where they switch to electric. This is all possible already today. We can do, as I said, the fleet management. With all the data we collect, we can support our customers in planning the routes. We can support them with, actually, as I said, the real-time driver training. We can actually take in the vehicles for service exactly when they need to be in, so we can do flexible maintenance. This really can cut cost and fuel savings with up to 15%, just with having this knowledge and this data. And we can actually, when we know about the operation so much, we can actually guarantee the uptime of the operation as well. We are doing the first platooning project, one driver in the first vehicle and the others follows. We do this in Singapore between the two harbor terminals. This is saving up to 7% of fuel, but the main driver is actually the lack of skilled drivers, particularly in this part of the world. We are operating our first autonomous trucks in a mining operation in Australia. It's going really well. This is typically where we see that autonomous vehicles will be applied first, in sort of confined areas, airports, mines, harbors. They are not yet ready to be in full city operation, but we are starting here and it's working quite well. Why is everyone talking about autonomous? Well, basically because most of your costs as a transporter will go down. Up to 40% cost savings are possible with autonomous vehicles. So that is really the main driving force, maybe not so much the sustainability. We have also introduced the next. It looks like a bus. It is fully electric. It is autonomous. It is a concept vehicle, I should say. What we do with this one is that actually in the peak hours of the day, it operates as a bus. During the low peak hours of the day, it can operate as a waste collector truck. You just change the top. You use the same chassis. And in the night, it could be a silent delivery vehicle, meaning that your city can actually replace 3 vehicles with 1. Summing up then again, the most important comment I want to make is really that technology is not the problem for decarbonization of transport. All the solutions we need are actually already available. We can cut CO2 with 90% already today with the existing technology. If you look at the publicly procured transport in Sweden, it's 86% fossil-free. So it's basically the public sector leading the way here. But the technology developed here, for the buses in particular, is actually the same technology we use for the trucks. So everything is actually here. We need, if we want haulage to go the same way, we need long-term, we need functional policy to come in place. In the industry, we have invested, so we are definitely ready for this. And if you now look at the bus sales, we have 40% non-diesel sales today on the bus side, soon making diesel the alternative fuel. So this is really happening and it is possible. In our own truck operations in Europe, we have a big truck operation transporting vehicles and material between our factories and our storages and our business units. We have over 10 years reduced CO2 emissions with 70%. So this is definitely possible. At the same time, we reduced cost with 15%. So we can do it. If we can do this, every other customer can do it as well. This is the Swedish policy. We want to be carbon neutral in 2030, and we have just commented on that, saying that applying all the different technologies that we have whizzed through now, it is fully possible to be carbon neutral already by 2030. All the different efficiency measures we talked about, and then half of it would be quite a big chunk of biofuel for the heavy-duty sector. Then we can actually be carbon neutral by 2030, which is the policy of Sweden then. We know also that we can do this everywhere because we have these type of commercial big-scale projects running on all continents in different transport missions. So, final slide. We really need to do 2 things. We need to speed up the implementation of the here and now, and we need to push the innovations that are ongoing if we should really be able to decarbonize within 12 years. Unfortunately, and particularly in Brussels, the politicians seem only to be able to have one love at a time, and today the love is the future. Only looking into future technology, spending most of the budgets for research and development. It's a bit sad. What we need now is actually implementation. Otherwise, we will never reach the 12-year target. So ending up with the clever man from the 1700s, Mr. Voltaire, he said, "Do not let perfect be the enemy of good." Please remember to do both things, implement the here and now and push the development at the same time. It is really not difficult. Thank you very much.
Thank you, Jonas.